Hello all. Good evening all. All right. Let's look at what we have done previously. Last week, we talked about this resultant force. Right. We do how. I taught you how to solve this kind of question. Right. This kind of question. Right. This is what we have done last week. Right. If you are inside the leaf, what will you do? Right. How much is the reaction? Right. Or how much is this? All right. So we are going to see this one. All right. um we look at this question, right? This question is asking us to find the acceleration and tension, right? Ask us to find the acceleration and tension. First of all, now you need to label all the forces. One, weight, right? The force that going down, it is called weight. The force that going up, it is called tension, right? This one is weight, this one is tension, right? So how much is the weight? Right, mg 2, right? The weight here, this is a mass, mass 2 kg, right? 2 times 9.81, you got 19.62. This is weight pulling downward. Okay, now this is mg here, it is 3 times 9.81, right? So because of this 3 kg is heavier, so this object, it is going downward, this object, it is going upward, right? So now what we have is we are going to solve the equation at the left hand side, right? Because that we know that it is going upward, because we know that it is going upward, so the net force will gonna be, net force is FR will be big force, bigger minus smaller one, right? Big force is equal to MA. The bigger force is T minus 19.62. 19.62 is equals to MA. M, it is 2 kg. A, don't know. Alright, so you got one unknown, two unknown. So you got two unknown. You got two unknown, so you leave it as this equation, the first equation here. You leave it as the first equation. And then we are going to do this part right here. Right now, we are going to do the second part here. Right. We know that this thing, it is going downward. This thing, it is going downward. So the bottom force, it is bigger, the downward force is bigger. So 29.43 minus the tension is equals to your net force 3a. So you got the second equation. So to eliminate this equation, this is t, this is negative t, you just plus them, you just plus it, and it will be gone. Right, 29.43 minus 19.62 is equal to this one plus this one, right? 5a. So answer 5a is equal to 9.81. So you get your acceleration 1.962. All right. So from the second here, you are going to substitute this one into here, the acceleration, right? This one you substitute in, so t minus 19.62 is equal to m times a. So you got this one as your tension. So you solve both of this one, right? This is basically what we had done last week. Come to do one more, which is something look like this, right? Same thing. All right, so this is the question, right? Whereas 2 kg trolley is this pulled by the pulley, right? So you need to label all the forces in, right? This is the weight, this is the tension, right? This is the weight, this is the tension. All right, so the weight is 19.62. We have done it. 5 times 9.81, you got 49.05. This object, it is going downward, right? This object, it is going to, this trolley, it is coming into this way. And then there is two more forces that we didn't put in. I didn't put in here. So which is weight and reaction. Weight and reaction here, it is no use because it is not contribute to the movement of the trolley. No, it is not helping the trolley to move at all. No. I didn't put it in. I don't put it in. So now, yeah, this is the thing that I do wrong last week, which is my question don't give the frictional force. So I give you frictional force as 10. If not, cannot do. So we are going to do this part, alright, do this part. Whereas the weight minus T is equal to my MA. The weight minus the tension is equal to MA. The weight 49.05 minus tension. Minus the tension. How much is the tension? We don't know. MA 5A. So we got the first equation here. We got the first equation, and then we are going to solve the second equation. Not solve. We are going to build the second equation, right? So this equation, how? T. This thing is moving to the right, so the T it is bigger. T minus the frictional force 10 is equal to 2A. So you got the second equation. When you got this second equation, so you are going to solve them, right? Negative T and positive T, you plus them. 1 plus 2 gone, right? No more T, right? 49.05 plus negative 10 is equal to this 2A plus 5A, right? 2A plus 5A, it is 7A. So you got 49.05 minus 10, which is 39.05, is equal to 7A. So we got this one. We got this one. Right? This one. And then you solve them, you get the A. A is this answer here. A is this answer. A is the answer of here. Right? 5.579. Right? 5.579 is your answer. Alright. And then if the question asks you to find the tension of the rod, so what do? You are going to substitute this one, right? Whereas here, up to you which one, 1 or 2, but I substitute this one because I find that it is easier. Move this one. T minus 10. T minus 10 is 2A. So where is your A? T minus 10 is equal to 2A. T minus 10. T minus 10 is 2A. A is come from here. Substitute it in. So you get the answer 21.16. This is what you gonna do, right? To find the acceleration and the tension of the rod. And this is what we have done last week, right? And there is few more questions that we got not enough time to do, so we are going to solve them, and then after finish, then we are going to see what is resolution of force. All right. So diagram. Oh, I make it bigger. So diagram 20A shows a car race and at this and diagram 20B shows an aeroplane moving with an acceleration at a constant altitude. Now the keyword here you have to be careful here, which is constant altitude mean constant height, right? With acceleration, got acceleration, right? Aeroplane moving with the acceleration and constant height. All right, so we know that this one, it is a weight of the car, so they called it as WC, right? WC is weight of the car. This is called normal or reaction, right? Now this one, W of the aeroplane, right? Weight of the aeroplane, and then U is the lift force that they gave, right? G is the drag is mean the diaceretan, and thrust, forward thrust. All right. So now this one, they said car at rest mean the up force is equal to the down force because it is not moving. So R is equal to WC. I find R is equal to WC. No. R is WC. No. R is WC. Yes, you are correct. This one is correct. R is U. Right. This one no. This one not yet. Not yet. So the first one we know definitely wrong already. So we look at this one. So this one is said that it moving with the acceleration accelerate forward. Accelerate forward, so your forward force have to be bigger than the backward force. So I said F is more than the G. So I go and find F is more than the G. Don't have. Right, leave it. Don't have. Don't have. And constant altitude. What does constant altitude mean? It is not going upward and it is not going downward. In upward and downward force, it is the same. Upward force, it is U. Downward force is WA. So U is equal to WA. We need to know U is equal to WA. Yeah, this one is correct. Just now, this one also correct, right? R is WC. Yeah, answer is C. Answer will be C. Answer will be C. Is that okay for you? My answer will be C. Wait, I just changed new computer so that you see my, that one will be different. Oh. Wait, transparent. Color is like transparent. Wait, give me 1 minute. I forgot how to do it already. Oh, hmm? E. Okay, one more try. Aduh, how? Transparent. Hmm? E. I forgot how to do it already. Where? Shame on me. Yeah, I don't want black color leh. Black color. Oh, this one. Okay, I know already. This one. Yeah, like that. Okay. Alright, I'm sorry. We wasted a lot of time here. Alright, so next one. That is a passenger, 60 kg in the lift. Alright. Calculate the magnitude of the normal force R when the lift moving upward with the acceleration. So we need to label all the forces in first. Right. First of all, this one, they said moving upward. The force is moving upward. Right. The thing, it is moving upward. So the force here, acceleration is going upward with here. Acceleration. Acceleration. Alright. The thing is, the lift is going upward with the acceleration. How much? Right. The acceleration is 1.5. It is given. Right. 1.5. A is equal to 1.5. M is -2. Right. And then what else? What else? Now, here we know that this guy is 60 kg, so that it must be a weight. How much is weight? The weight is W is equal to mg. W is equal to mg. So where the W, it is equivalent to, right? W is equal to m times g. M is 60 times g, 9.81. Right? So whereas 9.81, so we got the 60 times 9.81. So we got 60 times 9.81. 60 times 9.81. So you got 550 at 0.6. 5 at 0.6. 5 at 0.6 Newton. Alright, this is the weight. Hard to see. I put it here. I put it to here so that you can see. Right, the weight. I put it to here so that you can see. I label it one more time. E, right, W, right, and then this is the R, right? So how much is the R? We know that this thing, it is going upward. Going upward, which one is bigger, right? So your net force gonna be MA, right? Net force is equal to MA. The net force will be F. F is bigger R. Why bigger? Because go up. R bigger, then it will go up. If W bigger, then it will go down. So R minus weight. How much is the weight? 558. 588.6 is equal to MA. M is 60 kg. Right, 60 kg. Acceleration 1.5. It is given 1.5. So what do? Right, we need to find the R. Right, need to find the R. So this one move to here, become plus. Alright, you plus 60 times 1.5. 60 times 1.5. So what will you get? You get 678.6. R is 678.6 Newton unit. So answer can be C. Is that okay for you? Answer will be C. Okay. I hope I'm not too fast. This one we have done it last week. Alright, how to do it. Now this one is resolution of force. Alright, resolution of force, we are going to do it later. Now we do this one first. Diagram 15 shows the two people that pushing a large box with the force 1 and force 2 respectively. Magnitude of force 1 and force 2 are the same. The box is equilibrium. This one is very important. Equilibrium. Right? Equilibrium. Which one is correct? So when equilibrium, right, mean left force is equal to right force. Right? I can say F1 is equal to F2. Right? So now you see the answer don't have, they want equal to 0. So you bring it to the other side. F1 minus F2 is equal to 0. So F1 minus F2 0, F1 minus F2 0. This is right. If you don't want, you can bring this one to here also. F2 minus F1 is equal to 0. This one also correct. Right. This one also correct. So you got this one and this one, both are correct. So which one are we going to use? Right, normally. So we are going to take normally to the right as positive. Right. So the positive F1 minus the negative F1 is equal to 0. So this one is more correct. Right. But this one, if no other answer, this one will be okay also. Alright. So answer will be C. So we are going to see next. Alright, this one is got anchor one, but actually this question is not related to any anchor here. It is not related. So we still can do it. Alright, so we try to do it first. F1 and F2 and then F3. So we know that this one is F1, this one is F2. So F1, right? F1 plus F2. Right? Now F1 plus F2. So you need to see whether this one move or not moving. If moving with constant velocity, mean equilibrium. Right? So we read the question. Diagram 7 shows 3 forces F1, 2, 3 acting on a large ship. Pulling force by the two small board cause the large ship to move at constant velocity. Constant velocity means equilibrium. Right? Equilibrium is your net force is equal to 0. So you need to come back to here. This is your resultant force. Resultant force. So you can say answer. We look at the answer here. Right? So this one F1 plus F2. Right? F1 plus F2. F1 plus F2 is equals to F3. Yes. F1 plus F2 with this one is called vector. Right? This one is called vector. So you no need the 60 already with this vector. If know this error here, then you will need to write or cos 60 or sin 60, we are going to see. Alright, so is equals to the force to the right, meaning that this one, it is equivalent to a force that pull to here, and here it will same as here because of it is constant velocity. Right. Right, answer will be right. Now if I just want to if this thing is not move with constant velocity, what gonna happen? Meaning that not moving constant velocity is a small board is going to pull the big board, and then it will come into this acceleration, meaning that these two forces pulling, it is greater than this. F1 plus F2 is greater than F3, then it can happen with acceleration. If smaller, if we not moving, equal, right? F1 minus F2, this one minus salah, it is plus, right? So answer is A. If they say acceleration, then answer is B. All right. This is the one that I mentioned to you, right? So you see, teacher need to memorize formula. All right, what for you memorize the formula? This formula is not in the textbook, right? So now which one is true about the apparent rate, right? R, right? They said R is reaction apparent rate. So now, so this thing is going upward, right? So accelerate upward, right? So upward is bigger. R minus mg is equals to ma. So now for the situation of x, so I bring this one to here. I want R is equals to m, and then ma plus mg. So you factorize the m out, a plus g or g plus a will be the same thing. So ma plus mg, ma plus mg plus ma, same, right? So this one is correct. This is other all wrong. You don't need to continue already. But anyhow, I want to continue. For situation of y, this thing is going downward. Downward mean mg is bigger. If not, how to go down? Mg minus the upward force R is equals to your net force ma. So I bring this one to here, become positive. I bring this one to here, become negative. Mg minus ma is your R. So mg minus ma, yeah, correct. Mg minus. Lastly, constant velocity mean up and down, it is the same, mean equilibrium. R is equal to mg. No need to see. I taught you last week. Right, so answer is D. Easy? Yes, very easy. You need to memorize this formula? No need. Don't waste your time. All right. 25. We are going to see 25. Number 25. Diagram 20 shows a lorry at rest. F1, 2, 3, 4 are acting on the lorry. Alright, F1, F2, F3, F4. F1, F2, F3, and F4. Which one see it move forward with start to move forward? Start to move mean you need to accelerate. If not accelerate, how to start to move? Means starting it is at rest. So you start to move, you got an acceleration. So when you got an acceleration, if not, you cannot start to move, right? Why it is not like continuous to be on like one? Right, it move forward. So it move forward mean F1 and F2, which one bigger? So that it will move forward. F1 or F2, which one is bigger, so that it will move forward with acceleration? F1, yeah, very good. So I want to find F1 bigger than F2, boleh. F1 salah. F1 same salah. F1 smaller salah. Right. Now I want to see this lorry move up or move down. Answer me. Up or down? Move up or move down? Now this teacher is so bad, keep on cheating me. This lorry, it is move up to the sky or go down into the soil, go down into the ground. No, it is not. No, it is flat, going left right only. Where go up down? So I said it is not going up or down, right? So this one is the same. So this one C. Cantik sekali. Answer is C. Keep on cheating you, yeah. Good. Okay. Now this one. So we are going to do it together. We are going to do this one together. So that is a force that going downward, right? That is a force that going down. Don't want to use this one. That is a force that going downward. It is called weight, right? How much is the weight, right? How much is the weight? W. W is equal to mg. Why small? 11, right? W is equal to mg, whereas the m is 12 kg, g 9.81, right? So we got F is equal to mg, right? M is 12 times 9.81, right? 117.72, right? 117.72 Newton, right? Now there is another force that here that is called tension of the rod. This is called tension of the rod, and here also one tension of the rod. And then one more, that is a weight here. W is equal to mg. W is equal to mg, right? M it is at time 9.81, at time 9.81, whereas you get 78.48. 78.48. Alright, so I got both all the information in already, but still got one more. Alright, I want to know this one heavier, it's go up or go down? This one is heavier. This question give you this one go down, this one go up. Yeah, correct. So if you know it already, so we are going to solve it from left hand side. From the left hand side. So from this one, or this one. Okay, from here. So I'm going to do this one. So this one, I write the equation first. I write it to here, right? So now this one, because of it is going upward, so I mean T is bigger. Bigger minus a smaller, 78.48 is equal to your net force, MA. M, 8. A, don't know. So I got the first equation already, right? This is my first equation. First equation. First equation. Alright, so I want to write the second equation right now. From here, I want to write this equation. Because of this one is going downward, so I said down is bigger minus smaller is equal to MA. Help me. Bigger minus smaller, right? So 117.72 Newton. And Newton don't put in, later you confuse. During calculation, I don't put in unit. Alright, later you will get confused. You got other A or T or what. Alright, later you apply to N is what? It is an unknown. No, It is not an unknown. Minus t is equal to MA. MA is 12A. Right, 12A. So now this is my second equation. That second equation. Now solve them. Solve it. T, this is positive T, this is negative T. Eliminate. So I use the first equation plus the second equation. You cannot need to write this. It is okay if you don't want to write. Right? So you plus it, you get 117.72, 117.72 minus this one, right? Plus this one, plus negative 78, so minus 78.48 is equals to 12A plus 8A, 8A plus 12A. So you got 28A there, out there. So now you minus this number. You see, I normally lazy to press, so this number minus this number 117.72, then you'll get negative number, but this one big minus small should get a positive number. You got 39.42. I know it is 39.42, but teacher, this one negative because I purposely use this one to minus this one because I lazy to press, right? And then divide by negative 20 because this one is here is negative, so I divide by negative, then it will give me a positive low, right? Divide by negative 20. Then I'll get 1.962. So A is 1.962. MS negative 2. MS negative 1.962. So answer will be this one. Right? I hope you are okay. This one is important. You see all the Form 5 students right now, when they ask this. Cikgu, how to do this? Cikgu, how to do this? You so hard ka? No. Actually, if you know how to write, you label all the forces in, then everything just solve. Right? So now next one. Which of the following has the largest acceleration? Which one give you biggest acceleration? So if you want to have an acceleration, is F is equal to MA, right? You want to have acceleration big, so your force have to be big, net force, resultant force, right? So this one acceleration you want to big, so this one have to be big. So this one, the resultant force is, all of them are 2 kg, 2 kg, M is all the same, here, M all the same. So this one, the net force is, F is only 2. Resultant force is 2. This one, the resultant force is 24 minus 4. It is 20. Wow, so big. This one is, resultant force is 15. This one, the resultant force is 10 minus 7. It is 3 Newton. So which one give you the biggest? So that one will be your biggest acceleration. If you calculate it, you will get back to the same thing. So you don't need to waste your time to calculate it. Right? I coba calculate. Right? So I try to calculate. This one, F is equal to MA. Right? F is your net force. 2 is equal to M. 2A. A gonna be 1. Right? This one, 20 is equal to 2A. Wow, 20 divided by 2, it is 10. Wow. One biggest. 15 is equal to 2A. You see it? These all will not give you the biggest one. Only this one. This one. This one I'll tell you later. We do it later. This one we do it later. This one we do it later. This one is not related to this one because this is all syllabus 2020. But I put it in. I purposely put it in because I takut later got any kind of question come up with energy. Need to know also. Right? We are going to do it in future. Right? Alright, so we are going to do this one. Let me see. Tension, acceleration, all this. Alright. Now, come to the structural question. Diagram 4 shows a monkey has a firm hold at a tight rope that passes over a frictionless pulley and attached to the 15th branch of banana. Right, the banana. So the monkey and the banana are in equilibrium. Equilibrium mean the resultant force is equilibrium. Mean the resultant force is how much? Equilibrium. Equilibrium mean the resultant force is how much? Equilibrium. Equilibrium mean the resultant force is 0. Yeah, 0. 0 Newton. Right. Label, you see, indicate the force, the direction of force. Label all the forces acting on the monkey only. Monkey, monkey. Yeah, good. So this one is the label all the force. This one, label all the force. So this one is called tension. This one is called weight. Right? Do they ask you to count? Not yet. But later lah. Right? So label all the forces in. Now this banana, they are not asking. Right? Indicate the direction of forces. Label all the forces acting on the monkey only. 2 mark. Right? What is the weight? Weight. Mg. Weight of the monkey. M. We go and see how much is the monkey. Right? Don't have. The monkey weight don't have. But I know that here, that is another thing. Put it. Right? Another thing, put it. It is also called weight. Right? But this weight I got. Right? So this branch of banana is 15 kg. Right? 15 times 9.81. 15 times 9.81, I will get 15. $147.15. Right. Now, I want to ask you, this thing is not moving, right? Banana and the monkey is not moving, right? Why it is not moving? If the banana is heavier, then the banana will go down. If the banana is lighter, then the banana will go up. Now, why it is in equilibrium? Mean it is, they said in it is in equilibrium. Why it is in equilibrium? Mean the weight it is the same. So indirectly, what is the weight of the monkey? The weight of the monkey will gonna be this weight, 147.1. Right? So 147.15 Newton. Right? So of course, right, because of that one we didn't show, so we have to answer in this way. This one is weight mg. M is 15 times 9.81. Right? So which is same as the banana. Weight of the banana. Weight of the banana. Right? Okay? Another monkey, the mass 12 kg, saw the banana and jumped toward the banana and hold the end of the rope X. Where is rope X? I want to see rope X. Rope X. Right? Another monkey, another, not this one, next monkey, with 12 kg, saw the banana and jumped toward the banana and hold the end of the rope X. What happened to the motion of both banana? Right? So now it is jump. He saw the banana and then he jumped. Right? This monkey, right, jump toward the banana. Right? Meaning that this question not so good. It is not asking jump toward the banana. Where you jump toward the banana? Right? At least let me know. Right? You see? Now if it is from here, the monkey and jump toward here, then okay. So now I think it is he saw this monkey is see the banana, right? Not jumping from to, so he jumped toward here, and then toward the banana, right? But it need to hold here, right? If not, they will not ask you about the rock X. You see, now the question said, jump toward the banana, right? So the jump toward banana always lead misunderstanding to us, right? So now jump toward the rock X should be, right? So easier for us to understand. What happened to the both banana? Just now, not moving already, right? Now got one more. Not banana, monkey jump toward here, right? Right, jump toward here. So this one, the weight is 147.9, already equilibrium. But this one tambah some more. Then what happened to both of the I would say what is here? What will happen at here? The question asks, what happened? What happened to the motion of both monkey? Go upward or go downward? Moving upward or moving downward? Downward. But moving downward is not good enough. Still got a little bit of mistake. Is there any better answer than moving downward? Is there any other better answer than moving downward? Is there any other better word than moving downward? Because you're a net force, you got a net force. Because you got a net force. So you should write yes. Accelerates downward. Yeah, this one is better than moving downward. Moving downward already give you 1 mark already. But if accelerate downward, there will no way to minus your mark. Moving downward can mark you wrong. Moving, I don't know whether moving down constant velocity ka acceleration, because you got a net force, right? So you will have a better word of acceleration. Calculate the acceleration, right? So now acceleration, now this one, the total weight is W is equal to mg. Calculate the total weight first, including the second monkey, right? mg, m is 12 plus 15 is 27 times 9.81, right? Which is 27 times 9.81. 264.87. 264.87, right? Newton. So hard to see, lah. Can I move to other way that can see here? Alright. Okay, so now this one is moving downward, 2 monkey, so this one minus t. So the t I haven't labeled here. This t label here better. And then still got acceleration. I want to label acceleration. This is acceleration. This is so I'll do this one first. Bring to here. So I'll do this one first. This one is the going down, it is bigger, minus t. Now, because of this one, they never ask you to find the you see whether they ask you to find the t or not. Yeah, right. So you have to do both equation, right? So now I do the first equation. 264.87 minus t is equal to ma, right? 264 point what at 7, 264.87 minus t is equal to MA. MA is the total mass of the monkey, right? 12 plus 15, it is 27A. This is the first equation. Alright, this is the first equation. Alright, so I want to write the second equation. I am going to write the second equation. Second equation will be, now here, this one minus this one. This one minus this one. T minus, because this one is going upward, so T is bigger. T minus 147.15. T minus 147.15 is equal to 15A. This is the second equation. So I need to solve them to get the answer. Right? You need to solve it. So this one and this one I cancel. Right? So what I have is 264.87. I don't want to. You guys like to press 0, 0, 0. I don't like. Right? I minus. See, I minus 147.15. I don't need to repress. Is equals to this one 117.72. 117 E 117.72 is equals to this one plus this one. It is 42A. So A is equals to, you divide 117.72, right? This one divided by 42, then you get the answer 2.8. 2.8. Right? A is equals to 2.8. Right? A is equals to 2.8. Now I want to find tension. I simply sub into number 2 from 2. I'm teaching you maths. T minus 147.15. This one is equal to 15A. 15A. Right. T minus 147.15 is equal to 15 times A. A is 2.8. Right. Now the answer here, you see this one 2.8, it is already round off. I use the one that without round off, time 15. I no round off at all. And then bring this one to here, become plus 147.15. 189.2. Yeah, that's all. Some 4 mark. See, easy to get a mark, easy. Right, this one 1 mark. So how to get a 4 mark here? One equation 1 mark, 2 equation 2 mark, and then calculate acceleration 1 mark. Substitute to get this 1 more mark, 4 mark. This one got anchor. I skip first. And then this is 2021. Alright, all syllabus. Never mind, we are going to do it. Energy, we don't do it. Right. Okay. So let me see this one. Okay, so we can do this one. Johor 2021, right? So diagram 6.1, right? We read the question together. Diagram 6.1. Diagram 6.1 shows a boy is playing with a this skateboard. We move with constant speed. Right? Constant speed means equilibrium. Diagram 2, this boy, right? It is playing and then it's increasing speed mean accelerate, right? So accelerate. First one, constant velocity, right? Mean left and right it is the same. This one mean this forward force is bigger, right? Forward force is bigger. So when he push his leg harder and faster, so this one moving faster. Now, what is the resultant force? Resultant force is a single force represents the one or more than one force act into a specific direction. So resultant force mean you got one force, you got two force, you got three force, you got four force, I don't care, but all together become just one force, right? One force represent them all after you minus, right? All right, 6.1 and 6.2 construct the type of the motion of the boy in the word of acceleration. So now first one, 6.1 and 6.2. 6.1, right? 0 acceleration, right? I should write diagram 6.1. I didn't write because not enough space. 6.2, right? Type of the motion, it is acceleration. I don't know whether it is constant acceleration or not. The question not saying. This question not telling me increasing speed, right? Never tell me whether constant acceleration or not constant acceleration. But I know that this is an acceleration. Okay. Resultant force acting on the boy, right? Resultant. What is the resultant force acting on the boy? In diagram 6.1 and 6.2. 6.1, the resultant force is FR is resultant force is 0, right? 6.2, the resultant force is not equal to 0. I don't know how to write not equal to 0. Not equal to 0. Right? So meaning that if you want to say, right, resultant force is the forward thrust is bigger than the air friction. You can set it. Forward thrust is bigger than the what's that called? The friction. Right? Now 6.1 and 6.2 contrast. Forward thrust with the air friction, alright? So for 6.1, forward thrust is equals to the air resistance. Because constant velocity, the word of constant velocity. 6.2, diagram in diagram 6.2, right? Forward thrust is greater than, right, air resistance. Now I know some of you is joining my the lesson lab, right? That's why you feel difficult right now. Apa cikgu you cakap, if you follow from the beginning, you will not, you feel like this one normal lah, right? Because you don't follow, right? Early, not following, so you find it susah lah. Okay. You try to follow. If you need the front video, you can go and search, or you can PM me. I give you, right? Set the conclusion relationship between the type of the motion with resultant force, right? So resultant force when the resultant force is not equal to 0. When the resultant force is not equal to 0, what gonna happen? Tell me. What gonna happen? Answer this one for me. Alright, they want relationship. When the resultant force is not equal to 0. When the resultant force is not equal to 0. Okay? What gonna happen? Answer me. Answer. Right? When the resultant force is not equal to 0, so the when the resultant force is not equal to 0, the object accelerates. Or the skateboard, you can answer me skateboard, yes. Or the other way, you can answer another way, but I don't answer another way. You can answer another way. When the resultant force is equal to 0, the object is moving with constant velocity. Also can. When the resultant force is equal to 0, the object move with constant velocity. Next one. 6b, state the conclusion relationship between the forward thrust and the resultant force. Right? Relationship is conclusion relationship between forward thrust and resultant force. Right? So the larger the forward thrust. So what happened? The bigger the forward thrust, not the larger the resultant force. Teacher, I don't understand. Right? Most of you answered. I don't understand. Right? So this one, air friction already fixed. Right? 5 Newton. Then let's say 5 Newton is 5 Newton. So you can push your leg to move the skateboard. This one, right? Let's say this is 5. I said this friction is 5 Newton. Now you can push your leg to make this forward thrust. Right? They want forward thrust. Right? 10. Then your resultant force will be 10 minus 5. So your resultant force is 10 minus 5. If this one I increase until like 20, mean the bigger the thrust, the bigger the forward thrust, the resultant force will be 15, will be bigger. The larger the resultant force. Okay. If the mass of the boy of the skateboard it is 60 and 2.8 respectively, and accelerate with 3, calculate the forward thrust, right? So assuming the air resistance is 14, alright? So I draw it and then you do it for me. What's the answer? I drew it for you, the skateboard. Skateboard including the boy, So now they ask you, right? This one is the forward. I don't know how much, but the acceleration A is 3. The backward force, it is air resistant, only 14. This one I name it as F lah, right? T, sorry. Forward thrust. I name it as T, right? You do it for me. Calculate the forward thrust. Calculate the forward thrust. 2 mark. This mass is 60. Sorry, I forgot to label the 60 and 2.8. I forgot. Then you calculate and then give me your answer. Calculate and give me the answer. I believe you can do it. I really believe that you can do it. Come on. I believe you can do it. I can show you the answer. $202.4. Any other answer? Johor 21. Johor 21. Johor 20. Johor. Ini ada jawapan. Right. Question number 6, huh? Show you the answer. Yeah, you are right. Good. Very good. Good. Right. So, this is the answer. But I didn't give you lah. Right? If you want, you can screenshot. Right? I give you some time and then you can screenshot it back. Yeah. You just draw it out. If you not drawing out, then you feel difficult to do it. If you draw it out, then senang lah. We got susah. Okay. F is equal to MA. The net force is T minus 14 is net. Is equal to MA. MA is 60 plus 2.8. And then the A is times 3. Big minus small, T minus 14. Cannot 14 minus C. 14 minus T, this thing is not going to move. Right? T is, you calculate and I copy answer and 202.4. 202.4. 202.4 Newton. That's all. Okay. One more, last one. I want to go to resolution of force already. Stat the change would be if the skateboard is replaced with another board with a mass of 5 kg, right? As he continue his motion in 6.2, right? Now, here, friction still the same. They never said friction change. Friction 14. No change. Now, this T, I don't know. T is 202.4. Right? T, that one, right? The M, right? M is changing 60 plus 5 right now, kg. Can you help me to calculate the acceleration? Oh, no. I calculate. If you calculate too slow. F is equal to MA. Right? This one become heavier. It's easier for it to accelerate or harder for it to accelerate. Right? F 202.4 minus 14 is equal to 65A. Calculate the A. Just now the A is 3 right now. Happen. 202.4 minus 14 divided by 65. You get 2.8. Oh, just now 3, now 2.8. Oh, but they never ask you to calculate. You see the answer. Oh, the acceleration decrease. Why decrease? Heavy lah, heavy. Susah want to move. You want to move heavy, then harder to move. Right? You don't say harder to move. Acceleration decrease. You see, that's how the question will ask you, right? You follow step by step, it should be not a problem for you to answer. Is there any question? Any question before I continue with resolution of force? This one is the student pening pala. When come to this part, oh, susah, cikgu, I don't know. Oh, most of the student, this part cannot do at all. All right. All right. Let's continue. No question, Now here, we are going to see how to use the sine and cos using this resolution of force. What is mean by resolution of force, right? Previously is resultant force. Resultant force is I got one force pulling here, you got one force pulling here. The result of the force is here. Resultant force. Now, resolution of force is right now I got this force. I got this force only. I got this force. This force, it is equivalent to, I can resolute it to two direction, right? Meaning that this force, I can resolute it to one direction and one direction. I can resolute it to two. This force, I can break into two, right? One, it is go to the left, one is going to the horizontal, one, it is go to the vertical. That's why we call it resolution of force, right? Resolution of force means one force break into two, right? Two components, right? Previously is resultant force. Resultant force is many force, right? We combine, become one force. This one terbalik, resolution of force. Now, I don't want you to use the method of your school teacher one. I want you to focus into my way. My way will be the easiest way, right? Even my student right now in Form 6, when they come back and ask me question, right, they still said, school one tidak faham, right? Use my way, sekejap, you can do all, right? Just one way only, right? But I will explain to you the principle, why, right? But you just follow why. All right. This one you no need to copy, just listen only because it is useless, right? Now, let's say this is a theta. This is a theta, right? So now this force, we are going to call it as force, right? This one is because of y-axis, we call it the Fy. So go to the Fy. And then this one is called x. So we call it force to the x-axis, right? Horizontal force, vertical force, right? Horizontal force and vertical force, all right. So if I want sine theta will be equivalent to opposite over hypo, right? This is called opposite, this is hypo, this is adjacent. Adjacent, this is opposite, this is hypo. Right? So sine theta is equal to opposite over hypo. Fy gonna be, right? Sine is opposite over hypo over hypo. Hypo is F. So if I want to find Fy, I want to find Fy, this F, it is going to move upward. So it is called F sine theta. Is my Fy. So I rewrite Fy gonna be F sine theta. Finish. This one I guess you still can understand, but no use to understand it. Right, done. Cos theta is adjacent over hypo. Adjacent is Fx over hypo is F. So I time the F up. F cos theta is equal to Fx. I rewrite Fx gonna be F cos theta. So now Fy, F sine theta. Fx is F cos theta, right? Fy. Now I want you, this one if you understand it already, if you want to use this way, right, I let you go ahead. You want to follow your teacher one, go ahead. But if you follow my one, okay, I want you to see this theta right now here. See, This is my force. This is my force. You see this red thingy here. This part, right? Touch the theta or not? See, F touch the theta or not? You see, touch the theta. Yes, touch. Use cos. I want you to memorize this. Touch use cos. Oh, F cos theta. Touch then cos theta. Right. So what do you have is fx. I bring to fx already. Fx is f touch theta. F touch. You see touch. Touch theta cos. F cos theta. F cos theta. Fx is equal to f cos theta. Now this force, if I bring to here, you see where is that theta? Theta is at here. Theta here. Theta is at here. When theta is there, I bring it upward. Do I touch the theta? No. Not touching theta, but I still use theta. Not touching, not touching, then I use sine. Not touching, sine. Touch, cos. Not touching, no touch, touch, got cos, right? Cos theta, right? Touch, cos theta. Not touching, sine theta. Okay, now you see when I pull this, alright, if you can understand this, alright, now I do this example letter. Now you see when I got a question here, now a lot of them student will ask me, alright, including not under my tuition one, alright, you see they will ask me, teacher, x axis always fx always cos. I said mostly lah, I can say mostly, but always no. 30 and right, this is fy, this is fx. Okay, now I want you to understand this. No, I give you easier way. This one is kind of hard. Put this way, 30 here. Right, this one's senang first. Right, so we do the example letter. We see this one first. You understand it first, Understand it first, Now fx is okay. Now I do it here. Fx is equals to 10. Touch 30 or not touching 30. Fx, you want to become fx. Touch or not touch? Touch or not touch? Touch or not touching? Answer me. Touch or not touching? Touch, touch use cos. Right? Touch use cos. Alright. So 10. Then 10, touch 30. Touch 30. So press your calculator. 10 cos 30. Right? And cos 30. So you get 8.66. This one is 8.66 Newton. Now come back to here. The one that I taught you before. The one that I said before is you draw triangle. Okay, you draw triangle. This is 30 degree. This is 10 Newton. This is Fy. This is Fx. Cos 30 is equals to adjacent over hypo. Adjacent is Fx. Hypo is 10. 10 go up. 10 cos 30. This is my Fx. You see susah or not? You rewrite Fx is 10 cos 30. Wow. 10 cos 30. 10 cos 30. Fx. What's wrong? I know this one is the concept. This one is the way. But I do it this way to make you easier to do it, faster to do it. Touch, not touching. Alright? Alright, I hope you can understand. All right. Now, I don't want to write off that one. So now here, when I come to here, fy. Fy is when I bring this one to here. This one you have to be careful. A lot of students they get wrong. This one, when I come to here, I touch 30 or not? When I bring to fy, do I touch 30? Do I touch 30? Do I touch 30? You see 30 is here. 30, no. No. So, no, then I use sine. But sine what? 10 sine. Sine still sine this angle. Sine 30 is 10 sine 30 is, press calculator, you will get, it will be 0.5. You press calculator, you get 0.5. 10 sine 30. What will you get? You get 5. 5 Newton. Now, come back to here. Oh, sine theta is equals to sine 30. Sine 30 is equals to opposite over hypo. Right? Opposite is equals to fy. Hypo is 10. This one come to here. 10 sine 30 is equals to my fy. Fy gonna be 10 sine 30 is 5 Newton. Yeah, you are wasting time. You are wasting time. But I want you to be very, very careful. Some of you like to do it this way. After I taught you, you understand already. You like to do it this way, which is I don't recommend you to do it. What is the way? Simply, when I bring this one to here, now teacher, this is 90, right? How much is here? How much is here? I want to ask you, how much is here? This is 90 degree. This is 30 degree. How much is this angle? How much is this angle? Tell me. How much is that angle? Answer me. What is that angle? I'm sorry. This angle is 90 minus 30, right? It should be 60, right? Okay. Now you see fy. I bring to here. Touch or not touch 60. Touch or not touch 60. Touch or not touching 60. Touch, touch, I use cos. Right? Fy is 10 cos 60. I press calculator, 10 cos 60. Press calculator, 10 cos 60. Right? Fy is, okay, I repress, 10 cos 60. Okay. Oh, 5. How much is Fy? 5. Teacher, this one 30 or yes, this one 60 or yes. See whether you touch or not. If just now I said I bring this one to here, I touch 30 or not. Not touch 30, you use sine. If you want to say 60, then you see touch or not touch, you use cos. It will give you the same result. But don't calculate the angle on your own. They give theta, they give this angle, you follow using this angle. Don't show off. I know your maths is good. You want to calculate this angle for me. Don't you get what I mean? You get what I mean? Okay. Is that okay for you? Huh? One more time. You play with this one first, right? When I bring this one here, I bring down. I talk about 60 right now. Touch or not touching 60? Touch or not touching 60? See properly. Touch or not touching 60? I never said 30. I said 60. Touch or not touching 60? Fx is not touching. Not touching. I use sine. Touch cos. Not touching sine. 10 sine 30. 10 sine 30. Okay, press calculator. 10 sine 30. Eh, 60. Sine is not 30 already. If I say sine 30, it is touch already. You see, touch 30. So I mean 60. Sorry. Should be, you see? Tak salah ha. That's why salah. Not touching 60. Not touching 60. Right? 10 sine 60. 10 sine 60. 0.866. Oh, your fx 8.66. Okay. Now, if you understand this one already, yeah. When you understand this one, all right. Now, I want you to see. Okay, here. Now, example number 7, right? You can see that is a force here. That is a force here, right? Now, they want to find a normal. What is normal? Normal mean 90-degree force here. How much is the normal? Okay. Now, if I pull here, right? I pull here 20 Newton. This 20 Newton is not all contribute to the right hand side. No. Some of them will contribute to the right. Not all. Is that okay? Not all forces will contribute to the right hand side. Now, some force it is going to contribute to the right hand side. Some of them will contribute upward. Now, if you see from here, this is the object. I pull here 20, pull to the right. This force 20 all go to the right. This 20 all go to the right. If I pull some force at here, now this force I can resolute it into 2 directions, right? Some of them go to here, some of them go to here. Mean this not all 20 it is going to pull to here, right? I can show you the experiment here later, right? Not later lah, now, but my camera already set my. Wait me 1 minute Hey, wait, why cannot? Hey, ui, wait my camera not working. Hey, I'm hang. Oh, I know already. Okay, wait okay. I want you to see this. See? My calculator. Here, I push it with 20. I push it with 20. So, it will be 20. Alright? 20 all contribute to this side. If I push here 20, slower. Why? Because this 20 here, some of them is bring this calculator to the right, to the left, I'm sorry. This some of them is contribute downward, so that you find it is harder to push it, not really move. If I bring to here, 20. If I bring to here, quite okay. If I bring to here, little only, it moves little only. Why? Because of this force resolute into here, only sikit. right? Not compared to 20, it is a lot. This one, little. Okay. Now, uh, one minute. Let you guys know how do I do. I just go buy. I just go buy one graphic card so that I can do this. If previously my computer cannot because it is too lagging, my graphic card cannot support. Now come back to here, right? Come back to here, so we can see it here. This object, when I push it with 20, when I push it with 20, wow, it is moving strong, fast, right? Like that. It is, wow, can accelerate fast. If I push like that, wow, cannot. It move very slow. If I move like that, wow, even slower. If I push it this way, it is not going to move to the right. Because this force, it is all downward, not go to the right. So that's why we need to resolve it. This 20 here is equivalent to how much is fx. So we can sine or cos it. Do you get the idea here? Do you get the idea here? Alright. So this 20 here, it is actually contribute to how much to here. Right? This 20 here, it is how much contribute to here. So we can say, oh, the first one, this force, this force 20 Newton contribute how much to here? This one. So before we start, then we try to draw label all the forces in first, right? We label all the forces in. So this is the force that going down. Previously we had learned it. Oh, this one is called weight. Weight we can answer. Alright, mg. How much is this? M is 2 times 9.81. 2 times 9.81, you do so many times, you know 19.62. Cross your eye, already know. Right? 19.62. This one, you got one force, go to upward. To support it so that it will not go down. Right? This one, it is called reaction. Alright? So, now, we are going to find the normal reaction right now and find the acceleration. So, first of all, we are going to find F is this thing is not going to move. This thing, it is not going to move up and down. I said not going to move up and down. I never said right. Left, right, yes. You pull here, of course it moves. But you pull here, this thing, it is not going to move. Right? So, now up and down. Up is equals to down force. The force going to the up is equal to the force that going downward. Right? Right? The force that going up is R. Plus the force that going up is here, plus one more force. Force that going upward is R, and then one more, 20 watt. 20 watt. Sine or cos 30. Sine or cos 30. Sine or cos 30. Help me. This is 20 sine or cos 30. Here, touch or not touch 30. You bring to here. 20 sine 30. Why sine 30? Because not touching 30. Not touching 30. Right? R is 20. R plus total that going up. 20 cos sine 30. Is equal to the force that going downward. This is total force that going upward. Is goes to the total force that going downward. 19.62. Then you can find the R. This one, you are going to bring it to this one, 20 sine 30, you bring it to here, become minus. So press your calculator. R is 19.62 minus 20 sine 30. You get 9.62. 9.62 Newton. I'll do it other way. I will do many ways to let you understand. You choose way that you think it is the most. Now, just now I do say this one you want to show off you want to show pro this one is 90 degree, this is 30 degree, so this one gonna be 60 degree. Now if I do it this way, I don't recommend you to do it, but you can. Upward force is equal to downward force. Upward is R plus 20 plus 20 touch or not touching 60. The total go up. You see this arrow go up. This one also go up. Touch or not touching 60. Touch 60. Touch 60 is 20. 20 plus 60. Touch 60 is equal to the force going down 19.62. How much is the R? How much is the R? I calculate 19.62. 19.62 minus 20 cos 60. 20 cos 60 is 9.6. Same. As long as you know touch or not touching, then you will be okay. Even you change the angle, you calculate properly lah, and you will get 9.62 back. No problem. Now I am going to do the way that I think it is hard. I think so here this is a force that 20, you need to draw it. Draw it. So this is a force that going, this is the force here, right? And this angle it is 30, you draw it. This one is 20, yeah, we draw it here. This is Fx. And this is Fy going up. This is Fx. Right? I want to go up. Sine is opposite over hypo. Sine 30 is equal to opposite over 20. Fy is equal to 20 sine 30. And then the force that going up and down is the total force that going up is equal to the down force, right? The upward force is R plus 20 sine 30. R plus 20 sine 30 is equal to the force that going down, 19.62. You like this way? You like this way? You like this way? You don't like it, right? You need to draw triangle. You need to sine cos tangent. You need to why not I just touch or not touch, then okay already. I just touch or not touch, everything just stop. You understand what I'm saying here? Just touch or not, that's all. Right? I hope you can follow. Right? Now second one, right, we are going to do this. I know this one is kind of hard for you, but you will get better and better, right? So this 20 I want to bring to here so that the force pull to here how much, right? The force pull to the right, and then that's the frictional force, right? Frictional force is 2 Newton. The question set one. Frictional force is 2 Newton. Question set so this one is 2 Newton. So the force go to the right. Okay. Now left right Now it is left right. Now left or right it is bigger. I want to ask you, if this one I pull, this one frictional force, this one 20, I drag to here, pull this way, this object will go to the left or go to the right? This object is going to the left or go to the right? It will go to the left or right? Answer me. You will go to the left or go to the right hand side? What do you think? You go left hand side or right hand side? If of course it's go right hand side, I told you friction will not make it move. So the right must be more than the left, right? Right force is more than the left. Mean it will accelerate to the right. So now F is equal to ma. Alright, this one is not equilibrium already, not equilibrium, because it is accelerate. Up down is equilibrium. Left right it is not equilibrium because it accelerates. Right? Fr is 20 watt. Fr is 20 watt minus what? This force is 20 watt. 20, it is not fully 20, it is 20 something. 20 watt. Touch or not touch? I want to get you. 20 watt. 20 cos 30. Why cos 30? Touch. 20 cos 30 minus the frictional force 2 is equals to 2a. Right? So I can calculate the a. Right? 20 cos 30 minus 2 divided by 2. Okay. 20 cos 30 minus 2 is equals to, then divided by 2 equal to 7.66. 7.66. A is equal to 7.66 ms minus 1. ms minus 2, I'm sorry. Now, I want to let you understand this. I'm doing very, very slow here. Right? This 20, I want you to see. Yeah. This angle, let's say, I want you to do together with me to make you understand better. This is 20 Newton, and then this one is 10 degree. Right? Help me to calculate force Fx how much? Fx. I want to calculate Fx. Fx how much? Calculate and then answer me. I want that value. Hmm? 20. This value. Right? 20 cos 10. 20 cos 10, it is actually equal to 20 cos 10 equal to, but most of it, because the angle very small, most of the force it is contribute 19 to here, just little contribute to other place. If I pull here 20 cos 30, 20 cos 30, 20 cos 30 is 20 cos 30 is 17.32. 17.32. 17.32 Newton. It is contribute to here. Why lesser? Because this one go up already. Some of them is come to here, but still got most of it is come to here. If this one, if I put it this way, I put this way. Why cannot? Why I cannot draw? Why I cannot draw? How come I cannot draw? Can I? Eh? Hang ah? No leh. Wait ah. I cannot draw suddenly. Never mind. If I got a force of here 20 Newton, this is no angle. Is 20 fx 20 cos 0. No angle, 0. 20 cos 0, touch 0. How much is this? How much is this? 20 cos 0. You press the calculator, you will get 20 cos 0 is 20 because it is fully go to the right. So you don't need to cos it because it is going to the right. Cos 0 is 1. 20 times 1. Alright. So now if you understand this, now you see this one, the acceleration is 7. Acceleration is 7. You pull, just now you pull 30. 30 degree. 20 and then this 30 degree. This is 45 degree. It will, which one? Example 17 or 18 will accelerate faster. More force will contribute to the right. Which one will accelerate faster? 17 or 18? There's the answer there. Yeah. Huh? Which one accelerate faster? You know, right? It is 17, right? 17, why 17? Because more force, right? Because more force contribute to the downward. Okay. Now, here, if you understand, why wait. Let me solve it first. Okay. Now I want to draw all the forces in before I answer, right? So I want to help you to answer, right? Here, that is a weight. Why my this one becomes suddenly like fixed? I don't know what do I press become some. I cannot draw. I don't know what happened. Give me 1 minute. Why like that now? Now it's not like that. Yeah. I changed the new computer. Now my setting all run. My setting all cannot work. I'm sorry. Give me 1 minute. I plan to give you quiz today one. Oh, yeah. I don't know what do I press until I cannot. Okay, never mind. Try to do it. Okay, now come back to here. This is the weight, right? The weight is going downward, right? The weight is going downward. Hard for me. Right? The weight is going downward. All right. W is equal to mg. What happened? Cannot write. I don't know what happened. Ish. Geramnya. W is equal to, I use freehand. Mg. M 2. G 9.81. You got 19.62 Newton, right? And then here, that is a force named R. Okay. Now, this thing, it is not going up and down, so I want to calculate the normal reaction. Up force is equals to the down force, number one. The force that going upward is equals to the force that going down. W, right, and R. Okay, total force that going up is R plus something, 20 watt. 20 watt. 20 touch or not touching. Not touching this 45. Not touching. We use sine. 45 is equals to the force that going downward, 19.62. So R will be equivalent to 19.62 minus 20 sine 45. You will get it as 5.48. 5.477, 5.48. So you get it as 5.48. 5.48 Newton. Alright. Now, here, that is one more friction. It is 2 Newton friction. Now this one move to the right, pull to the right, so that it will accelerate here. 20 something 45. 20 something 45. Touch 45, right? Cos 20 sine 45 minus the friction 2 is equals to 2a. I can find the a. Right? 20 sine 45 minus 2 divided by 2. I'll get my a 6.07. 6.0. So ugly, I use my handwriting to write. I don't know why suddenly cannot work. This thing cannot work. You see, you keep on. I don't know what's wrong with the thing that one. Okay. You see how it is work. Don't know how to fix it. I never happened this one before. This one I never had. Don't know what should I get wrong. What? I cannot. Okay. Are you okay with this? Any question from here? If no, then I will move to here. Alright, this kind of question is normally students cannot do also. Right? So this kind of question I want to come back to where we had. Right? I said I will come back to do. Whereas it is here. Here. Yeah. Right, you see now what do we do is I want to add in some angle at here. This is the theta. And this one will be the theta also. This angle. Right. Why suddenly? Right. This one will become theta also. Why it always become theta? Now I need to explain to you why. Right? So now here, you see this one here and here. I take some angle in. Let's say this is 20 degree. Let's say lah. Alright. This is 90 degree. Okay, now this is called the surface, right? So R is always 90 degree to the surface. So that's why it into this direction. This is R, right? This is R. So this is a 20. Now weight always going downward. Weight always going downward. Weight is always going downward to the earth. All right. And then this angle, I want to know what is this angle. So we know that this one is 90. This one is 90, yeah? This one is 90. And then I want to find this angle. This angle is equivalent to 180 minus 20 minus 90. Minus 20 minus 90. 180 minus 90 left 90. 90 minus 20 left 70. So this angle is 7. This angle is 70. We know that this one is 90. This one is 90. Right? Here is 90. Yeah? So here already 70. So here it is supposed to be 20. And this angle same as this angle. And I am not happy with it. Hey, teacher, this one you fix it. Oh, you know? I fix it. Now, what if not 20 leh? Okay. 30 lor. This is 20, 30. This is an object. This is the weight. This is the reaction. This is a reaction. So I want to find this angle. This is 90. 180 minus 90, left 90. Minus 30, left 60. This is 60, yeah? And this is 90, right? We know this is 90. 90 minus 60, left 30. This is 30, this is 30. This is 20, this is 20. This is 70, this is 70. This is 50, this is 50. This angle is always same as this angle. Don't ask me why. It is happened to be like that. When I calculate, it happened to be like that. So this angle is theta, so this angle must be theta. Right? So this thing, now this one is called inclined plane. This one is called inclined plane. Right? It is not flat, not flat. It is inclined. Right? Got angle one. So when this object, it is not moving. This object is not moving. This is the angle. This one, the object is not moving. This is the R. You see, when I got this weight here, this is the weight. Weight. Now this one and this force must be the same. If not, then it will go up that way or go down this way. So it is not, it is going to slide down this way or go up this way. You pull, then it go up. It is not going this way and this way. It is going this way and this way. Right? So now, so this weight I pull to here. These two will be the same so that it is not going up or down that way. So I can say R is equal to W, right? Cos what? Right? This one got angle. Previously don't have angle. Now got angle. So when got angle, we need to put in cos. Cos what? Right? So now R is equal to W cos theta. R is equal to W cos theta. Why cos theta? Because touch. Now, either the object is moving constant velocity downward this way or upward this way, I don't care. Right? Accelerate this way or that way, I don't care because it is not going up this way or this way. So R is always W cos theta. Why cos? Because touching. Now this force, it is component of the weight down the plane because this is a weight. This is the weight. So this weight got one force, it is contributing to this direction. And then this one is called frictional force. Now if the component of the weight down the plane is bigger, so it will accelerate downward. Component of the weight down the plane, if it is more than friction, then it will going downward with acceleration. You can see here. If the object is moving with constant velocity, mean up and down it is the same. Up and down will be the same. This one component of the force down the plane, same as the friction. Constant velocity, equilibrium. Right? If F more, this one less, mean it will accelerate. That's the concept. That is the concept. Huh? Now come back to here. Where? Alright. Come back to here. Now I need to label all the forces in. It already good. Here, now. This is called weight. This is called reaction. And then I need here. This is called theta. Alright, this is the thing that I want. This theta how much? This theta is same as this angle, which is okay. This theta is here. So first one, I want to find normal reaction. Normal reaction. R is equals to this R is equals to, because this thing is not going up and not going down this way. So it is equals to this one, this one, come to here. Touch 30 or not touch 30? Touch 30 or not touching 30? Touch, right? Touch, right? Touch, then I use cos. Touch, I use cos. Is equals to W. W is 2 kg. 2 times mg cos theta. Wait. Hey. R is equals to mg cos theta. No, I don't know how to write theta. Right. Now. Is there any question? So I can say R is equals to mg. M is 2 times 9.81 times cos theta. Cos theta is cos 30. Then how much is this? Help me. You press your calculator. 2 times 9.81 times cos 30. You get 16.99. Yes, 16.99 here. Same. Newton. Right. This is the first one. Right. This is the first. Now, here, I said this thing, it is going to slide down from a smooth inclined plane. What is smooth? Smooth means no friction. Smooth means no friction. Meaning that the friction here, it will be equal to 0. No friction. Right? Friction here, 0. No friction. No friction. And this force, it is going to pull it downward. This force is going to help me pull it downward. Now, very easy. Why? Why this inclined plane, when I put it to one object here at a smooth surface, this thing, it is going to slide down? Because got something pull it. What is that? Weight. What is that? Gravity. So that it's going to pull it is down. It is going to go. Right? So I want to see how much is this force. I want to see how much is this. I want to see. This force is W. Touch or not touching 30. Don't say this 30. I am not going to call you this 30. I am going to call this one and this one. The anchor is here. The anchor is here, not here, not here. This one is teacher touch this 30. Oh, that one is other place. You don't take it in. Touch or not touch 30. Yeah, touch or not touch 30. Or you need to see whether touch or not touch 30. Yeah, not touching that 30. Not touching that 30. You gonna use sign. You are going to use sign. You are going to use sign. So this one is this one, right? F is equal to MA. So I will just write W sine theta minus 0 is equal to MA. Okay. I don't get used to it. Okay. Okay, number 2, I will just say you see, I will just say this W I bring to here, not touching my 30, not touching this 30. This W not touching 30, I use sine. W sine theta minus the one that pulled it up is equals to the MA. Right? W minus R is equals to MA. So what do I have is W. W is mg. W is mg. Mg sine m. I straight away put in 2 times 9.81 sine 30 minus the friction. Minus friction is equal to MA. M, it is 2. A, I don't know. I can calculate the A. 2 times 9.81 times sine 30. 2 times 9.81 times sine 30 minus 0. Minus 0 is still no minus. And then divided by 2. My acceleration was 4.905. I know it is kind of hard for you to accept this one, right? I know it is kind of hard, but you see, if I don't use this way, teacher don't want to use this way lah. All right, you will feel more suffer, right? So whereas sometimes I also do it wrongly. Okay, see how I do All right, this one I will do it next week. So I explain how the triangle work. This one is called R, right? This one is called weight, and then normally this one is called friction, right? So you have to draw the triangle first, right? The triangle will be this way, R, and then this one is W, right? And then this one is called frictional force, mu. And then you need to label all the angle in. This angle is 30 here. So you need to find where is the 30. Where is the 30? Right? This R. This is W. What is this angle? Right? You need to find what is this angle. This angle is same as this angle. Because this is W, this is R. This is W. And then this in between is 30. Yeah. And then this is 90 then. This is 90. Sine is opposite over hypo. Cos is adjacent over hypo. Cos 30 is equals to adjacent over W. Right? W come to here. R is equals to W cos 30. Then you'll find R is this one only. Then I still need to minus. Alright. W cos 30. W cos 30. Yeah. You still need to draw everything out to find it. It is kind of hard. I tell you, don't use it. It is kind of hard. Okay. Now this way, come to this way even worse. All right, you want to find friction, right? You want to find this one, right? Uh, 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 this force is not called friction. This is the force. I name it F lah. Right. Sine 30 is equals to F over F over W. Right. W is mg sine 30 is your net force of this one. Mg sine 30 is equals to your net force of this one, which is 2a. I tell you, it is kind of hard. So you see, very easy. This one touch or not touching. That's all. Touch force. R is equals to this one. R is equals to 2 times 9.81 mw cos 30, then you get the answer. If this one is, you want to come to here, not touching 30, you sine, right? Mg sine 30 minus the friction. Unluckily, this friction is 0, right? Unluckily, this friction, right, is equal to ma. Then you will solve everything. I do one more, last one, number 20. Now I level everything in, right? I do it fast. Here, that is a weight, and then here, that is an angle 30, and then that is a R. This is R. This is W. Right, this is 30. Right, this is the 30 degree. This is 30 degree. Okay. Now find the acceleration. They never ask you to find the R. You no need to bother about the R. And then there is one more frictional force at here, which is 2 Newton. Which is 2 Newton here. One more frictional force here is 2 Newton. Now this thing, it is going to slide down because of the gravity pull it, the weight pull it. Here pull more than 2. If is equal to 2, then this thing will move with constant velocity. If this one is more than 2, then it will accelerate down. So I know this one is accelerate downward. This thing is going to accelerate down. Accelerate downward. So now, what is the component of the weight down the plane? Help me. Resultant force is W what? W what? W touch or not touching? W what? Touch or not touching? W. Bring to here. Touch or not touch? Touch or not touching? Touch or not touch? So, W sine 30, very good. Right, is equals minus the friction. So the force W sine 30 is here. W sine 30 minus 2 is equals to 2A. W I know. W I know. It is 2 times G. 2 times 9.81 times sine 30 is equals to 2A. And can find the A. 2 times 9.81 times sine 30 minus 2. Hey, where is my minus 2? Then minus 2 is divided by 2. I got set. One more time. 2 times 9.81 times sine 30 minus 2 equal divided by 2. 3.905. I know it is kind of hard for you, right? Now, if I want to know this one extra one, right? Extra one, the question not asking, so I know R is equals to Q. R is equals to W sine cos 30, touch 30. That's all. Right? But the question not asking. No. Do you understand? Is it too much today? Touch. Right. The lesson today is just touch, cos. Not touching, sine. You memorize that, will be okay. Touching, cos. Not touching, sine. That's all. Touch, cos, not. Any question from here? Today cannot quiz. Right? Finish this one, Baru can do quiz. Right? I need to finish this one and this one. Okay. Next week. Next week, a lot of anchor here. I tell you. Right? Next week. Next week lesson very important. Right? Any questions? Yeah. If no question, before I end the class, all right. You can share to your friend. Ask your friend to join before March. If after March the tuition fee will be slightly more expensive, right? Right. Tell them, ask them to join fast, register fast. Right. This is the last. I tell you one more time. This is the last free tuition. Right. Free. I called it as, what's that called? Free trial tuition. All right. Next month, right, if you want to join, all right, you continue, you have to fill in the form. You already they'll ask you, the admin will tell you whether you want to join or not. If you want to join, you need to pay. And then you guys, for those who haven't filled in the form that I asked you to fill your email, let me know your email. If not, I cannot put in into there. You cannot see. Your email must be Gmail. If no Gmail, go and create one fast. Okay. Now, thank you for the lesson today. I want to continue this. I'll redo. Any question? If no question, I'm gonna stop here. So okay. Thanks for the lesson today. Alright. Thanks for the lesson today. The logo blocked my face, Try to relocate some good position for my face, Bye bye. Good night.